All right, so Google's quantum AI lab, huh? Looks like we're going deep on their new Willow chip today.
Yeah, and you've really gone all out on the source material this time.
Well, it's not every day that Google claims to have a quantum computer that can outperform, well, everything.
Right, we're talking calculations that would take the world's fastest supercomputers longer than the entire age of the universe.
Hold on, longer than the age of the universe. Okay, now you've got to break that down for me.
So these sources are all buzzing about Willow completing a benchmark computation in under 5 minutes.
5 minutes. And what kind of computation are we talking about here?
Something called random circuit sampling. It's basically a problem designed to push quantum computers to their absolute limits, a way to prove they can tackle problems beyond the reach of classical computers.
So, like the ultimate quantum flex.
Yeah.
But what does that actually mean for us non-quantum physicists?
It means we're not just talking about speed here. It's about solving problems that would literally be impossible for even the most powerful supercomputers to handle, even if they ran for billions of years.
Impossible, huh? So, what makes Willow so different? It can't just be about processing power, right?
Right. It's like comparing an abacus to, I don't know, a super intelligent AI that can predict the future.
Okay, I'm intrigued, but also a little terrified.
Yeah.
Can you unpack that comparison a bit?
One of the biggest things is how Willow handles errors, a challenge that's been plaguing quantum computing for decades.
Errors, like blue screens of death,
Yeah.
but quantum.
Kind of. Imagine this. A regular computer uses bits, either 0 or 1. Quantum computers use qubits, which can be 0, 1, or both at the same time, through a concept called superposition.
Superposition. That sounds like something out of a Marvel movie.
Ah, right. It's mind-bending stuff, and it's what gives quantum computers their power, but also makes them incredibly sensitive to any disturbance, leading to errors that can cascade and ruin the whole calculation.
So it's like trying to build a house of cards on a vibrating table, one wrong move, and the whole thing collapses.
Exactly. And for nearly 30 years, researchers have been chasing a solution called below threshold operation.
Below threshold. What's so special about that?
It means the more qubits you add, the lower the error rate gets.
Wait, wouldn't more qubits just mean more chances for things to go wrong? That seems counterintuitive.
It does. But that's where Google's expertise in chip fabrication, qubit calibration, and error correction software comes in.
Ah, so it's not just about quantity, it's about quality and control too.
Exactly. Willow combines all of that to achieve this below threshold operation, which means errors actually decrease exponentially as the system scales up.
So they've essentially built a system where the qubits are, what, checking each other's work and correcting mistakes.
In essence, yes. It's based on the surface code, where qubits are arranged in a grid.
A grid, like a quantum spreadsheet.
Haha, kind of. By strategically measuring and manipulating these qubits, they can detect and correct errors before they spread.
So it's like a self-healing computer. That's wild, but how do they even know this is all working as well as they claim?
That's where those benchmark tests you mentioned come in. Willow ran that random circuit sampling problem and absolutely crushed it.
Crushed it, how? Give me some numbers to wrap my head around.
Willow did it in under 5 minutes, a calculation that would take a classical supercomputer, like 10 septillion years.
10 septillion years. I don't even know how many zeros that is.
It's a number so vast it's hard to comprehend. Billions of times longer than the universe has existed. That's how long it would take a classical computer to do what Willow did in under 5 minutes.
Okay, my mind is officially blown, but this can't just be about breaking records, right? What does this kind of speed unlock for us?
It means we're moving from the realm of theory into the realm of possibility. We're talking about tackling problems that were, until now, considered impossible to solve.
All right, I'm hooked. Impossible problems solved in minutes. Let's get into the nitty-gritty of what Willow can actually do, shall we?
Yeah, that's the real question, isn't it? Like, we've got this incredible machine, but where do we point it?
Okay, well, let's start mapping out some destinations then. I mean, the sources you sent mentioned everything from revolutionizing medicine to, tackling climate change.
And those are just the tip of the iceberg.
So let's start with medicine. I feel like that's one area where, well, the stakes are pretty high.
Absolutely. One area where Willow could be a game changer is drug discovery. Imagine designing drugs at the atomic level, simulating how they interact with the body.
Yeah, because right now drug development is such a long, expensive process.
Right. Years of research, billions of dollars spent.
So with Willow, could we actually shortcut that process?
It has the potential to, yeah. Simulating even simple molecules is a massive computational challenge for a classical computer, but for a quantum computer, it's practically second nature.
So instead of testing thousands of compounds, we could use Willow to pinpoint the most promising ones right away.
Exactly. It could drastically reduce the time and cost of developing new drugs, making life-saving treatments available so much faster.
That's incredible. And not just finding new drugs, but also personalizing existing ones, right?
You got it. Personalized medicine, that's another area where quantum computing could make a huge difference.
Because right now, it's kind of a one-size-fits-all approach to medicine.
Right, but everyone's genome is different. Those tiny variations can make a big difference in how we respond to medications.
And Willow could help us analyze those genomic differences.
Exactly. It could process massive amounts of genomic data to predict which treatments will work best for each individual.
That's amazing. But I have to admit, when I think about the power of quantum computing, part of me gets a little anxious. Are there any risks we need to be aware of?
Of course, every powerful technology comes with its own set of challenges. We need to be careful about potential disruptions to industries and the need for strong security measures.
Yeah, those are valid concerns. But for today, let's focus on the potential benefits. So besides medicine, you mentioned materials science earlier.
Right, materials science, that's another field where quantum computing could revolutionize things.
I mean, it seems like almost every aspect of our modern world relies on the materials we use, right?
Absolutely. Our buildings, our vehicles, our electronics.
And Willow could help us design entirely new materials.
Precisely. Right now, discovering new materials involves a lot of trial and error.
So lots of experiments in the lab, trying different combinations.
Exactly. But with a quantum computer, we could simulate the behavior of atoms and electrons within materials at an incredibly detailed level.
So essentially, we could design materials atom by atom, engineering them for specific properties.
Precisely. Imagine materials that are stronger and lighter than anything we have today, perfect for aerospace or construction.
Or materials that conduct electricity with almost no resistance.
Exactly. Or even materials that are incredibly efficient at capturing solar energy.
Wow, that would be a game changer for renewable energy.
Right. Quantum computing could help us solve some of our most pressing energy challenges. Imagine designing next-generation solar cells.
Or developing catalysts that can capture carbon dioxide from the atmosphere.
Exactly, and convert it into useful products.
So we're talking about tackling climate change at a fundamental level.
That's the potential. Yeah, quantum computing could help us transition to a truly sustainable future.
Okay, so we've covered medicine, materials, and energy, all fields that seem ripe for a quantum revolution.
And we're just scratching the surface.
What other areas are you particularly excited about?
Well, one that really captures my imagination is the intersection of quantum computing and artificial intelligence.
Ah, yes, quantum AI. That's been generating a lot of buzz lately.
And for good reason. Quantum computers could supercharge AI in ways we're only beginning to understand.
So how would that work? Would they be like training AI models on data that's too vast for classical computers?
Exactly. And they could also use quantum algorithms to process information in a fundamentally different way, leading to breakthroughs in, things like image recognition, natural language processing, even decision making.
So those sci-fi scenarios where AI becomes super intelligent, are we getting closer to that?
It's certainly a possibility, although we're still very early in the development of quantum AI, and there are many challenges to overcome.
Like what? What are some of the roadblocks?
Well, we need new quantum algorithms specifically designed for machine learning tasks, and we need quantum computers that are larger and more stable.
So it's not just about raw speed, it's about making quantum computing more accessible and useful for AI researchers.
Exactly. And that requires a real collaborative effort between computer scientists, physicists, engineers, you name it.
Okay, so it sounds like quantum computing has the potential to not just revolutionize industries, but also entire fields of study.
Absolutely. It's not just about solving specific problems, it's about changing how we approach problems, opening up new ways of thinking and discovering.
That's a pretty powerful thought. But are we getting ahead of ourselves? Is this all just hype, or is there a real chance that quantum computing will change the world?
That's the million-dollar question, isn't it? And honestly, it's hard to say for sure. We're still early in this journey.
So you're saying it's too early to declare quantum revolution, but the signs are there.
I think that's fair. It's a bit like the early days of the internet. Back then, few people could predict how profoundly it would change our lives.
And you think quantum computing could have a similar impact?
It's certainly possible. We're just starting to scratch the surface of its potential.
Okay, you've definitely got me feeling excited and maybe a little overwhelmed too.
It's a lot to take in, for sure. But that's what makes it so fascinating.
So where do we go from here? What are some of the specific areas where quantum computing could have the biggest impact in the near future?
Well, in our next segment, we can dive into some of those real world applications, things like finance, cybersecurity, even space exploration.
Welcome back to our deep dive on Google's Willow chip. And man, my head's still spinning from all this quantum talk.
Yeah, it's one of those things where the more you learn, the more you realize you don't know.
Exactly. So for this final part, let's ground ourselves a bit. Talk about some specific areas where Willow could make a real world impact.
Sounds good to me.
Now, you mentioned space exploration last time, and that always gets my sci-fi senses tingling.
Space, yeah, it's a field that's ripe for a quantum revolution.
Well, we're constantly gathering tons of data from space, telescopes and satellites and probes, right?
Right, and it's just too much for classical computers to handle effectively.
So could Willow actually help us analyze all that data?
Absolutely. Quantum computers are amazing at sifting through massive data sets, finding patterns that we'd never see otherwise.
So we could use Willow to make new discoveries about the universe.
Exactly. Identifying new planets, unraveling the mysteries of dark matter, all kinds of possibilities.
That's pretty mind-blowing stuff. But let's come back down to Earth for a minute. What about finance? I mean, that's an industry that deals with a lot of complex data and risk calculations
Finance is another area where quantum computing could be a huge disruptor.
because of all the algorithms and models they use.
Right, and those are getting more and more complex as the markets evolve.
So Willow could help Wall Street develop even more sophisticated trading strategies.
Potentially, yeah. Quantum algorithms could analyze vast amounts of financial data, identify hidden trends, make predictions about market movements with greater accuracy.
Hmm. That could be good or bad, I guess, depending on who's using those algorithms.
True, there are ethical considerations to keep in mind.
Speaking of ethics, what about cybersecurity? I mean, we hear all the time about how vulnerable our systems are. Could quantum computing help with that?
That's a really interesting question because quantum computing presents both a challenge and an opportunity when it comes to cybersecurity.
How so?
Well, a powerful enough quantum computer could break the encryption methods we rely on today.
So our digital locks could become useless.
Potentially, yes. But on the flip side, researchers are already developing new quantum resistant encryption methods.
So it's a race to build better defenses before the old ones fall.
Exactly. And the stakes are incredibly high. The security of everything from our online banking to government communications depends on it.
Okay, food for thought for sure. But man, this whole conversation has been pretty mind expanding. From space exploration to finance to cybersecurity, it seems like quantum computing could touch every aspect of our lives.
And we've really just scratched the surface. The possibilities are almost endless.
Yeah, I'm feeling a mix of excitement and, I don't know, a little bit of existential dread. Haha.
I get it. It's a lot to process, but it's an exciting time to be alive, to witness this new era of computation unfolding.
And it's been fascinating having you here to guide us through it all.
My pleasure. It's a topic I'm passionate about, and I encourage everyone listening to, keep learning about quantum computing. There are so many resources available online.
Great advice. And on that note, a huge thank you to all our listeners for joining us on this deep dive into the world of quantum computing. It's a field full of mind-bending possibilities, and we're really just at the beginning of this journey. So keep those questions coming, and we'll keep exploring together.